All right, your foundations unit really is just going to be a lot of topics that you either covered most likely in Algebra 1, maybe geometry. So a lot of this should be review of certain things. The way your notes work is that they're basically closed notes, and you kind of can put as much or as little as you want. There are going to be some times whenever we have notes that will have a lot of different examples, but time-wise, we won't spend as much. We won't spend all the time to go through every single example. We'll kind of let you pick and choose and do it go that route. So then we can make sure we get through everything, and then hopefully you have at least about 10-15 minutes to get started on an assignment that is there. So a lot of this stuff is not really in our book. It's kind of supplemented of things that I've used in the past or from other books or from other classes and things like that. Okay? But a lot of this stuff you will have seen before, and it's just going to be a large part of the review. So we'll probably move through this fairly quick. Okay? Throughout the year, whenever we do it, we will have things that we'll spend maybe 2 days on a section or maybe even 3. Stuff here in the beginning, it's going to go pretty quick in about 1 section per day. I'm not going to bog you down with homework. It's just going to make sure that we hit the ideas and make sure you're in the right place, you're in the right mindset and kind of know where you're going. A couple of goals. Basically, you should know how to use a number line to graph and order real numbers, and then identify properties of and use operations with real numbers. Basically, you can use a number line. You know where numbers go on a number line, and then the different properties that we use whenever we solve equations is really what we're doing. So, a little vocab. The graph is a real number of a real number is a point on the real number line that increases from left to right. You know what a number line looks like. You can start it really at any point. Usually we just count by ones and go from there. You may shrink it down, or like it's almost like you zoom in and go by tenths, halves, whatever. Number that corresponds to a point on the number line is what's called the coordinate. So whenever we say a point, the technical term of that is just a coordinate on our number line. The opposite or the additive inverse of any number A is negative A. Now, that works in both directions. So if I give you a negative number, like if I give you a negative 5, what's the opposite of negative 5? Positive 5, right? Same way if I give you like the number 6, the opposite of that is negative 6. Okay? So you can start with a negative value and have the opposite be a negative, or be a positive rather. Okay? It just works both ways. Yes is no, no is yes, kind of going back and forth. They're opposites of each other, right? Maybe. There we go. What number's right there? I'm just going to start from the left to the right. What's the first one on the left? Yep.
Negative 3 1/2.
Negative 3 1/2. What about the next one? Negative 3 over 2. And then the last one? 1, right? Okay, there may be times, sometimes to be perfectly honest with you, whenever you use fractions, they may be a little more difficult than others. Okay? Notice that in some of these cases, like 3 over 2, we just gave you the opposite with negative 3 over 2. Same way with 7 over 2. 7 over 2 is the same thing as 3 1/2. Okay, which is the opposite of negative 3 1/2. Okay? You may think of it as 3.5. Okay, or negative 3.5. So we got here, there. So then it says place coordinates of the 3 points in order from smallest to largest. So what's my smallest point? So of those 3 points that are circled, -3/2, 1, and 3 1, -3 1/2, which one's the smallest? -3 1/2, the one that's furthest to the left, right? Okay. What comes next? -3/2, and then 1, right? So your basic algebra properties. Okay, so whenever you were in Algebra 1 and you solved equations, you did these, you used these properties. You probably didn't write them out. Okay, but really it's like whenever we did a proof. Okay, whenever you were in geometry and whenever you guys did proofs, you had reasons behind everything you did. Right? So if you had reasons behind everything you did, if I have A plus B equals B plus A, that's a commutative property. As long as the two terms stay the same, if we switch the order, I can add them up and I'm still going to get the same value. 2 plus 3 is the same thing as 3 plus 2. Right? It's still 5. Same way with commutative property of multiplication. If I take A times B, that's going to be the same thing as B times A. 6 times 7 is the same thing as 7 times 6. Now, of these two, it went from commutative property of addition and commutative property of multiplication. Okay? If you can think about commutative, like commute, whenever you drive, okay, how many of you ride a bus? Okay, or drive to school or ride with somebody to school? Okay? Whenever you leave your house, you probably go the same way whenever you leave, right? Same thing, okay? So it's the same distance. You're going to travel the same distance. It's just basically you're going in reverse order. Right? It's going to be the same amount. That's not going to change. Now, what two are not up here? Or what two are not listed on your notes? Commutative property of subtraction and commutative property of division. Why can't we put those two on there? Because it doesn't work. Okay? I can't take 3 minus 2 and get the same answer if I go 2 minus 3. Right? One's a positive one, one's a negative one. It's not going to work out the same. Okay? Order doesn't really matter whenever we add and multiply. It does matter whenever we subtract and we divide. Then we have associative property of addition and, again, associative property of multiplication. As long as you're associating with the same things, we can group it differently. A plus B grouped together, if we do that first, and then we add C in there, it's going to be the same thing as if we group B and C together first, combine those, and then have A. Friday night we have the jamboree, right? Football jamboree. I don't know if the band's playing or the band will be there, but it's like if you have you and 2 other friends, right? It doesn't matter if the one friend that can drive picks up you or the other one. As long as they pick up the 2 other people, they're all 3 going to be in the same car, right? Does that make sense? Okay, it's like when you meet up, you're still all going to be together. It doesn't matter who came with who as long as you are together at the same time. Does that make sense? Okay. Same way with multiplication. We can multiply 2 things here. We can multiply B and C together first instead of A and B together. Okay? As long as we have C, as long as we have all the same parts, we're going to be in good shape. Again, just like the commutative property, there's no such thing as associative property of subtraction or division. Okay? Because there the order matters. Then we distributed. Basically, whenever you distributed, whoa. A multiplied to B, B multiplied to C, and we got AB and AC. Right? So we went A to B and then A to C. So anything that's outside, if there's no sign that's separating that parenthesis and that letter or that variable or that term, constant, whatever's out there, it's going to go to everything. It gets distributed to each part inside that parenthesis. Then, additive identity property. Basically, if you add nothing to something, you still have what you have. Everybody good there? You need me to go back? There you go. Good. So we had additive identity property, now multiplicative identity. If we multiply 1 to anything, it's just that value. Okay? Whatever that value is, whether it's A, whether it's 7, whether it's negative 322. If you multiply 1 to it, it is what it is. Then additive inverse property. If you had the opposite to anything, it's going to be 0. If you have two values and you have one that's the original and one that's the opposite and you add to them, you're going to end up with 0. Now, the flip side is the biggest mistake that gets made here is that whenever we do multiplicative inverse, is that students want to put 0. Okay? Remember, just think about whenever we multiply 3 over 2 times 2 over 3, everything's going to cancel. So when everything cancels, the A's are just gone. What's the only thing that's left? The 1 that's on top. Okay? Don't get into a bad habit. The biggest mistake, like I said, it's going to be a 0 here. Okay? And it's just a silly mistake that gets made. So don't be that person to let that happen. What did we do here? Of those properties that we just went through, what did we do? Distributed. All we did is we took the 3x to the x and the 3x to the negative 4. Is all we did. It basically just looked something like that, and this is what we ended up with. Okay, I don't know how you were taught. Whenever I distribute, I always draw lines. Okay, or draw the arc and just jump from one thing to the next. I don't know what you were taught before. It's completely up to you how you do it. So distributive property. What about here on the next one, if it ever gets there? Associative. They're associating with different people, right? We have 5x, we have y, and we have 2. Okay? Here, on the first one, y and 2 are associating together with each other first. On the other one, 5x and y are associating with each other first. Everybody's still involved. Okay? But it's just the associative property of, in this case, addition, because everything's addition. Yeah?
So if I find 3x times x, it would just be 3x, right?
Do what? Where? Are you looking here or what? Then, okay, so kind of your Venn diagram, your first little circle. Okay, you have what's called a natural number. Okay, I'm not going to go through the full definition. Okay, all a natural number is really it's just all your counting numbers that are positive and that aren't zero. Okay, so like when you count, what do you usually always start with? 1, right? 1, 2, 3, 4, 5, 6, so on and so forth. As we work our way out, we have whole numbers. The only thing different between a whole number and a natural number is that we throw in 0. So it goes 0, 1, 2, 3, 4, 5, so on and so forth.
Where are we supposed to do that on this?
Yep. You got the natural number inside. The only thing different between a natural number and a whole number is that it has one extra number, 0. That's it. Then, as we work our way out, we have integers. Integers deal with all of the whole numbers. We just go in the opposite direction. So instead of counting to the right and going 1, 2, 3, 4, we go -1. We just keep going backwards and we go -1, -2, -3, so on and so forth. Does that help? No? Yes?
Yeah.
Okay. Then, whenever we work our way even further out, okay? Oh, you need to add another circle in there. My fault. Are your rational numbers. Those are all of the terminating decimals and the repeating decimals. Okay, so like 2/3 is going to be 0.6 repeating. -2/5 is going to be like -0.4. Okay, it's a decimal that's either going to keep going on and on and on and repeating the same values over and over and over again, or it's going to terminate. Okay, it's all of those numbers in between your 1 and your 2. It's like a half or 2/3 or 3/4. Then that little bitty circle that's kind of off to the side. You have rational numbers that are in the green. Then we have the irrational numbers that are in the pink. Irrational numbers are those values that never repeat and never terminate. The most common one you're used to is pi. Okay, pi is one that usually you put 3.14 and you stop, but that's an approximation. That's not the actual value. It's the 3.141592 whatever. Okay, square root of 2 is another one like that. Square root of 3. A lot of the square roots or the cube roots that aren't perfect cubes or perfect squares, those are going to be irrational. And then wrapping the whole thing are what's called real numbers. That's every number that you can think of that's imaginable. Okay? That's not imaginary that we'll get to later. So where's -5 fit in? What's as deep as you can get into the diagram basically with -5? Integers, right? Why can't we go into here with the whole numbers? Because there's no negatives here. We keep all the negativity out here. Okay? Negativity stays out there. Only positive and no zeros in there. Okay? Okay, so it's an integer. So as we go, so if it says what type of number is it, well, it's an integer. It's a rational number. It's still a rational number. We can basically work, once you get to the furthest part inside, you work your way all the way out. Okay, so it would be an integer. It would be a rational number. It would be a real number. Okay, since it's negative 5 over 1, that's why it's going to also fit as a rational. Okay, still leave it as a simplified number. You're not going to write it as a fraction. That's just... Okay, and then just a little bit, just so you can kind of remember, what does it mean to be a sum? We're going to add. What does it mean to be a product? What are we going to do? Multiply. Difference. Subtraction. Quotient. Total. Addition. What about of? Ooh, discrepancy. I like it. I heard multiplication. I heard division. How many of you think multiplication? How many of you think division? It's going to be multiplication. Okay? You're still multiplying with it. Okay? You're still multiplying with it. Because whenever we multiply, it's like of, because it's is over of, right? If it's of a number, you're still going to multiply with that value. Okay? Even though you're thinking probably like a proportion, right? And it's division, but we're still multiplying whenever we're doing that. Plus is addition, minus subtraction. All right, last thing. It says elevation of Blue Springs is 974 feet above sea level. Elevation of Geiselman Lake, Imperial Valley, California is 162 feet below sea level. What is the difference between the two elevations? All right, first day of math class and we give you a word problem. Gosh, what is he doing? Where are we at? What are we thinking? How much?
1,136.
1,136. Did anybody come up with like 800? What was it? 812? Okay. Some did, but they got persuaded to go the other direction. Okay. Why is it 1,000? What's the number? 1,036? 1,136? Well, it's only 974 feet. How is it in the thousands? Yeah.
162 is kind of like the negative number in this instance.
Right. Okay. Because we're at Geiselman Lake in Imperial Valley, California is below sea level, so it's below the natural surface. Okay, we had to come up out of it just to get out of to basically to zero, and then work our way up. Okay, difference meant to subtract. Well, when we subtracted that negative 162, okay, that was below the surface, those two negatives, what did it do? It changed it to an addition problem, basically. Even though it's still difference and it's still subtraction, but where some of you got caught was that you didn't pay attention that it said below sea level. Okay. Now, your assignment it's on Canvas. If I need to, it's just 2 to 14 even, then the 16 to 25 all, and then 30, 32, 33. There's a worksheet on there. If I need to, I can email it to you because if Canvas isn't working. Okay? But you can just write that, like there's that box for the assignment that's there, but you're just going to do 2 to 14 even, 16 to 25 all, and then 30 to 32, 30, 32, and 33.